Sand dunes. What are they? Well, they're big piles of sand. Duh. Oh, sorry, it's going slowly. Where do they form? Well, they form where you have a good supply of sand, typically near a river or an ocean, and where you have a good supply of wind. Notice, not a lot of wind in Phoenix. No sand dunes. Northern Arizona, around Winslow, you get sand dunes. You have a lot of wind, and you have a lot of sand. The deserts along the Colorado River near Yuma, lots of wind, lots of sand. You get sand dunes. The Sahara, same thing. Now, a typical sand dune has a couple of sides. You've got the windward side and the leeward side, also known as the slip face. In a typical sand dune, it stacks up at 34 degrees. This is called the angle of repose. You know about angle of repose because if you try and stack up stuff in your street, let's say your parents ordered some granite for your yard, the granite over time will go down to what's called the angle of repose. Now, with the wind blowing from this direction, sand grains wink, 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 go across the top of this and slide down the slip face, so that over time, this sand moves from the windward side to the leeward side, and sand dunes really migrate. If you dig through a sand dune, what you're going to see are the old layers in it from the old slip face. They can be made of several things. In the case of this area of northern Arizona, they're feldspar. There's sandstone here with a lot of feldspar in it, hardness of 7. Uh-oh, forgot to stop my watch. No, start my watch. Oh well, we're going to wing it. Hopefully I'll stop before 15 minutes are up. Be patient, please. I'm starting my watch now. So sand dunes could be made of feldspar. They can be made of gypsum. In this case, in New Mexico, near Alamogordo, north of El Paso, there are some mountains that are made of gypsum. Well, the gypsum gets washed down in the rain, gets deposited and left behind as an evaporite, and then that gypsum gets picked up by the wind and deposited. The gypsum is very light colored, unlike the feldspar, so you end up with these white sand dunes, which gives us White Sands National Monument, right near the Trinity site where the first atomic bomb was tested in south central New Mexico. You also have hornblende, which will create black sand beaches, as in the case of Hawaii, plus somebody got a little creative with the rocks. And typical sand dunes are made of quartz. Why quartz? Well, out of all those things that we just listed, quartz tends to be the hardest. Beaches like this, the softer stuff wears away and the quartz is left behind. So most sand dunes are quartzy. This is the windward side. The wind blows from this direction. This is the leeward side. If you were to dig through the sand dunes, you would see little layers, or what we call cross beds, inside of there. If you want to be out of the wind, be over here. But don't stay there too long because eventually you'll get covered up. And sand dunes in areas like Florida or the Caribbean can be made of calcite because they're old shells. And sometimes you find teachers buried in them. These are old students from Sunrise Middle School a few years ago. Types of sand dunes. I won't go into a lot of detail here, but there are different types of sand dunes. In this case, this is on the western coast of Africa, and these long seif dunes are actually migrating into the city. Okay, we have Barkhan sand dunes, which are shaped, I don't know, what would you call this, parabolically? Actually, they aren't parabolic, they're reverse parabolic, but in, I don't know, like the thing you throw and it comes back to you, like a boomerang. This is the slip face, this is the windward side. You have transverse dunes, which are long. Some people call these longitudinal dunes. You have parabolic dunes, which are kind of the opposite of Barkhans, and they occur where you have blowouts just in front of them. And then these are the real longitudinal dunes, where the wind is blowing constantly in one direction. You get this whipping type of action or vortex action. So you get these long dunes. Again, this is like these seif dunes in northern Africa. Here's a beautiful Barkhan. In this case, this is the windward side. This is the leeward side. If you want to have a lot of fun, run up this side. Okay, that'll get you tired. And then jump down this side. And then scrape up all the sand when you're done so nobody knows you were there. It's hard to tell, but these also are Barkhans. The wind is blowing from this side. This is the leeward side, and here's the more shallow windward side. Windward, leeward. In this case, just the opposite. Windward, leeward. You'd run up here, woo, jump down there. Notice the sand is staying real close to the surface of the dune. It's not going in the air. The silt and the dust go in the air. Here are real longitudinal dunes. The wind looks like it's blowing in this direction. Parabolic dunes next to an ocean front. Great Sand Dunes National Monument, I believe in Colorado. Ah, beautiful. And again, here's a blowout with a little pedestal in the middle. Dunes migrate. In this case, like I showed you in the other picture, these dunes are migrating over the city. Here are some dunes migrating over a forest at Dune Park, Indiana, right next to the Great Lakes. These trees probably will die, or some plants have adapted to be covered for a period of months or years and then still come back to life. Again, here's how a dune migrates. So you don't want to build your house over here unless, well, you like dusting, or in this case, sanding. Here's what happens to a tree after it's been blasted a lot. I don't think this one is coming back. Desertification. In a big area of the world, because we're lowering groundwater, because we're overgrazing the land, and other instances, we are creating bigger and bigger deserts. Here's 40 years in the Aral Sea in the central eastern part of Russia. Here's what the Aral Sea looked like in 1964. Here's a 24-mile on a side square. So this thing looks like probably 200 miles long. By 1987, here's the Aral Sea, yellow line being the original outline. 1997, and then 2002. Here's all that's left of it. People used to fish in this. They used to get sturgeon out of it. Beluga caviar used to come out of this. Take a look at this little part right here because that's going to be the next picture. 1973, 1987, and 2000. Here we go. That, to that, to that. People that relied on this for their livelihood, well, it's going away. Here are the size of boats that used to ply the Aral Sea. No more. There's nothing that can be done. What's one of the causes of it? Center pivot irrigation. When you pump the groundwater out, it'll drain the lakes. This is what happens with a growing population and people wanting more and more food. A lot of this water doesn't go for food for us. It goes for food for cattle and then for us. It's kind of a crazy statistic, but each pound of beef that we eat uses something like 500 gallons of water. Don't quote me on that, but there is a real dramatic trade-off in the amount of water used to create a vegetable pound versus a beef pound. And this is the result of that kind of action. Australia, huge fires and desertification going on in 2012 and 2013. What's going to happen here? Nobody knows. This is down by Tucson on the way to Oracle. Notice along the roadside, pretty good grasses. On the other side of the barbed wire fence, though, pretty desolate. Why? Cows. In Arizona, we used to have grasslands. Early settlers reported losing their kids in the grasslands. The grasses were so thick and so high. We came along and thought, hey, grasslands, just like Kansas, like Nebraska, like Wisconsin. Let's graze 100 cattle on an acre. It didn't work very well. Once the grass was gone, the ability to hold the soil was gone, and the soil blew away. So we're losing our soil due to wind erosion and overgrazing. This is what it'll end up looking like eventually if we don't learn. Again, the Sahel Desert of Africa. People live in this marginal area right here. Little by little, the desert is creeping south. I have no idea what this is doing in here, but these are those sinkholes southeast of Winslow. How can you prevent erosion of dunes near beaches? Well, one, don't walk over the seagrasses. It sounds little, but in Hurricane Sandy, areas that had protected their grasses still had dunes, and with dunes, the houses weren't destroyed. People that had destroyed the grasses and the dunes got wiped out. Nature knows best. How do we prevent soil loss? It's pretty simple, really. Don't overgraze and plant trees. Why trees? Trees create windbreaks, just like these fences along beaches, along Florida, I believe this is, could be Alabama, create windbreaks. They stop the wind from blowing so fast, When the wind stops from blowing so fast, it drops its load, just like the river. When the really fast river comes out of the Rockies and gets down toward Yuma, slows down, it drops its sand, its gravel. It still keeps the clay and the silt and the dissolved materials, but it drops the heavy materials, including a little Dixie cup, it looks like. Here's a tree break or a wind break. It stops soil erosion. This is really fairly simple. And another thing we can do is contour plowing. Remember in the picture of a drumlin in glaciers, how the farmer had plowed around the hill? That's what we should be doing in hilly areas. Believe it or not, we just got through wind in 2 little sections. Good job. That is it for wind. See you in the waves portion.